We've looked at a large number of the major diseases we have, and we've looked for genetic mutations that correlate to those diseases. And in many cases, we have found genetic mutations, but pretty much across the board, it's in less than 1% of the population with the disease. Less than 1%. So it's good that we found some genetic mutations, but what about the other 99%? If you look at pretty much any of the major diseases, the increase over the past 20 or 30 years is so dramatic. In many of them, it's a 10-fold increase. For autism, it was 15 years, 10-fold increase. I'm sorry, there's no genetic mechanism known that could explain that phenomena. It has to be induced by the environment. There's hundreds and hundreds of environmental factors that are known to promote or be associated with disease. The vast majority of environmental factors cannot change DNA sequence. They're not mutagens. So how is it an early life exposure promotes a later life event? In terms of evolution, there's these rapid evolutionary events that basically we can't really explain easily with classic genetics. So there appears to be an additional factor that regulates how the DNA functions. It's not the DNA sequence and the genetics isn't absolutely critical. It is. But it appears that there's something else that's regulating how it works. It basically goes forward. So what I'm going to talk about is epigenetics. This is what the phenomena is. I'll describe in a minute. Epigenetics provides solutions for a number of the failures for genetic determinism. Again, I'm not suggesting that genetics isn't absolutely critical. It's just a small piece of a much bigger story. It also means what we're exposed to today is going to affect our progeny for generations to come. So this is a very different way to think about and a different mechanism for how disease develops. So, what I just told you is the environment has the ability to dramatically affect the epigenetics. This then influences how the DNA functions in terms of what genes are on and off. And these epimutations, these epigenetic epimutations that get put in place become a permanent constituent of the DNA. This then causes this change in what genes are on and off. And with the organ systems, if it's a normal biology, then you're going to have normal biology going forward. If there's an abnormal expression and there's abnormal biology, you'll have a susceptibility to develop disease. So in terms of another consideration is, this doesn't only affect disease etiology. You also have an increase in phenotypic variation. The characteristics that the individuals have within a population are different. This has direct impacts on natural selection and evolution. Therefore, environmental epigenetics may play a significant role in evolution, which we hadn't considered before. So it doesn't just affect disease, it affects really all of biology. Okay? So, essentially, as I started out, these are those ancestral ghosts in your genome, these epimutations that were put there through an environmental stressor. Now, what I just talked about is a pretty doom and gloom situation. What your ancestors were exposed to is going to affect your disease, and what we're exposed to, likely a different set of contaminants, we're going to pass on to our grandkids as well.